Hello and welcome back again. This is the part 4 and the last part of this series. In this part we're going to train the network. We save the model and predict the test data. First of all, I'm going to run this first. This is how we train the network before I explain this because it will take a while in training the network. Okay, so I'm going to put this and click run. Okay, now let's itemize this individually, line by line. So epochs means it's the number of epochs or the number um, of iterations that you go on through with all individual data in the training set. Okay, and now for each individual epoch, we're going to make a for loop here. Okay, the for loop is up to this one. Okay, so for the for loop, for each individual, for example, the epoch is 50 for each epoch in the range of epochs from 0 to 50. Okay, we're going to do some monitoring first. The next line is the correct prediction and train. So I'm going to explain this later on. Okay, so for every epoch, and we're going to load the feature and the label in the train loader. If you remember in the previous part of this series, we have this train loader defined as it has these X train and Y train data. Okay, so the feature are the X train and the label is the Y train in the train loader. So for every batch, the batch is composed of 100 as previously stated in the previous video. So in each batch, we're going to make a forward propagation. Okay, so output is equal to classifier. This is our object of the class net. Classifier and call on the method forward and input here the X train data which are the feature. Okay, you can put here X train or Y train, it's up to you. So output is equal to classifier dot forward and feature. Then afterwards we get in the monitor what are the output of this network. Okay, so as you can see here, there is a correct prediction in training set at 0. So basically we are going to compute of these how many of these predictions are correct. So on each batch or on each loop, this is on per batch basis. On each per batch basis, we're going to add this how many could correct prediction does the network obtain. Okay, so train prediction is equal to torch.argmax. Argmax means that it will just get from the output data of 10, that's 10 items, okay, 10 columns. It will get the argument the highest number in the 10 columns, and it will indicate or return the column with the highest number. For example, the highest number in column is column number 2, so from 0 to 9, so it will return here 2. Okay, so the dimension is equal to 1 because it will compare all the 10 columns, so it's vertically comparing. Okay, next, the correct prediction is initialized at 0. Then it will add this, how many of them, the train predictions, the numbers is equal to the Y train or the label, and sum it up and get the item. Because if we're not going to get the item, it will return a torch, uh, a tensor. It will return a torch tensor. So we're not interested in torch tensor. We are interested in the data inside the torch tensor. So we put it in item. Okay, so one batch here, it will add another one there. Next, after we get the output here from the forward propagation, we need to compute the loss criteria. How much of the output is different from the Y train or labels? So the loss is here. Next is also we need to monitor how much loss it is. So the running loss here is initially state at 0 on every epoch. Okay, and it will sum up the loss at item, the one computed here. Okay, so it will sum up. Next is that we need to reset the gradient to 0 first before we do the back propagation. Okay, reset gradient. Optim is an object as previously stated in the third, I think it's in the third video. Okay, then loss that backward computes for the back propagation. Okay, next, given this back propagation, we need to update the weights. Okay, so optim that step, it means updating the weights. Okay, and afterwards we have here the schedule that step, which is update the learning rate. So the learning rate varies from, as stated in the previous video, from minimum to maximum. Okay, so that we can optimize the training. Next is that after one batch here, we're going to stop the training first. Okay, and then we're going to, what do you call this, actually the loop here is just up to here. Okay, because this one is not included in the loop. So it will loop here until it finishes all all its existing X-train data. Okay, and afterwards we pause the training. We torch at no grad means the training is paused. Then we compute the training accuracy. So train loss is the summation of the loss over the total number of labels, or y train that shape 0. Y train that shape 0 will give you how many index or rows are there. Okay, the train data. So y train that loss, it is the running loss. Keep in mind that the running loss here is the one we sum up here. Okay, the running loss. So the running loss divided by the total, that will be the train loss. And the train accuracy, okay, is a correct prediction train. That one is also being computed here. Correct prediction train. And then we divide it by the shape of the total length of the training dataset. You can also use this here as X train, because X train and Y train has the same number of rows. Okay. Afterwards, we test the model using the validation data. So validation predict means we predict the validation data, which is X validation, X valid, and we make a forward. Then again, we get the maximum like what we did here, and then we divide again. We get here the summation of the total of this predicted and the y validation true value, and we get the item, and we divide it again by the length of the y validation or x valid. It doesn't matter. Afterwards, we print it out. So as you can see, when I print it out, so I print first the number of epochs, like here 1 out of 50. There's 50 number of epochs. Then we compute the training loss up to 4 decimal places here, and then the train accuracy up to 4 decimal places here, and then the validation accuracy up to here. Okay, so epoch plus 1, so I put it here to 1 because it will start at 0. Okay, that is why it is. So format epoch, epochs 50, train loss, train accuracy, and validation accuracy. Okay, that's it. Now it's finished training. The train accuracy is 1, and the validation accuracy is 0.9690. Okay, next is we need to the it is already finished training. Now we need to predict the test data. Okay, again we put it here torch.nograd so that it will not be updating weights, and then we put it here again, the same thing that we did before. Predictions is the classifier that forward using the x test dataset, and then these are all the same, and then we compute for the accuracy given the length of the y test or the labels. You can also use x tested shape here. Next, we print it out. Okay, afterwards we get a good testing accuracy of 0.9711. Okay, the next is we save the model. We can do that by just saving the classifier state dictionary, which are the weights basically. So we put it here, the classifier that state dict, we save that, and we save that in the file pytorch.mnistmodel.pt. I just put here the .pt in order to know that it is a PyTorch. Okay, so I issue the command torch.save like this. Okay, We save the model. Afterwards, after we save the model, we can now load again the model. This is simulating wherein we save a model and we load the model again. So that let's see if the model is still working. When loading the model, in this first line, second line here, we need to define again the architecture of the network. So you can see this is net again. So if you're going to load the model in another Jupyter notebook, make sure that you define again the network architecture like this one. The network architecture like this one. We define this again. We copy paste this whole block, whole cell. Okay, and you put here again the input size, the output size, which is the same from the network architecture of this classifier model. Okay, then we load afterwards. When this model is empty, we load now the state dict or the weights. We load it here. PyTorch the is we load. Okay, so now we have an output. All keys match successfully, meaning we successfully created a duplicate model from classifier into model. Okay, so these two models are the same, classifier and model. They are the same except for their names. And the last one, let's test this model again. Same again. So if we run this, the accuracy is 0.9711 using the test dataset. So as you can see, the testing accuracy of this one and the new model, which are basically the same, are also the same. Okay, so that is for now. Hope that you learn a lot in this series of lessons with regards to classifying. Okay, so if you like this series of videos, please subscribe and give your comments below. And that's it for today. So I hope to see you in my next video. Okay.